let's see, am I on? Let's see, starting? So wait, is it currently running or not? Live. We are live, apparently. Okay, about 10 seconds. Okay, cool. Alright, so students, you got this document on eCampus. This document is 8 pages, 3,914 words. And it contains some of the things that I thought would be most important for you to just review. Now, I did also give you specific sections of this based on your data to tell you which ones you should particularly study, maybe because you get all the other ones, but you might also, if perhaps you're feeling kind of weak in that exam, you might go ahead and do all of this. Up to you. It's all there. So what I'm going to do in this video is I'm going to go through each section and give just a little description of what's being said. If you don't understand what I say in a certain section, go back to it and read and do the Albert assignment that I might mention in there. So let's go and begin. First off is IP addresses. So an IP address is the address that internet packets are sent to when you need them. So when you try to access a website, it uses this IP address here to find out where it should send the information about the website back to. IP addresses are assigned to every single device that's connected to the internet. Now here's something to understand. The IP address is kind of location specific. It depends on what router you are registered. So like right now, I am currently still at school. So this IP address is actually for our school, not for my home. And now the importance of understanding that is the fact that your IP address moves with you. So if I were to now leave the school, leave my classroom, and go down to Taco Bell, then I'm going to have a very different IP address, because in that case, I'm now somewhere else. So the packets that follow a certain path of routing to get to me now have to follow a different path in order to truly to reach me. We'll talk about that a little more later. Let's talk about what's public and private and what you should be scared of. So, technically, by knowing the IP address of something, you are able to then, no, not command line. Oh wait, yeah, command line. You are then, oh wait, no, not Python command line. Command prompt. Okay. You are technically then able to ping it. Now, what is pinging, you ask? Not something you really need to know for this class, but I'll show you. Pinging is where you send your, oh, you know what? I should not ping the same one. Yeah, I probably shouldn't ping the place that I'm actually currently located at. So we're going to go ahead and try that again. All right, pinging is where you send a request to a certain IP address to see if there's anything there. So basically, it's where you ask it, hey, are you there? And if it responds, then yes, something is there. So for instance, the public address for Google's IP address, which again, Google's IP address is actually public. For instance, 888.8. If I were to try pinging that one, it would now send 4 packets at it and see if it replied to all of them. And it did, meaning that yes, 8888 is a valid IP address. Now, the importance of knowing an IP address and what you might be scared of there is the fact that denial of service attacks exist. DOS and DDoS attacks exist, meaning that if someone knows your IP address, they could technically ping it, a few million times and crash your service. They would particularly be doing this to a website, like maybe Google, but at the same time, most big websites like Google and all that, they have good security, so they're kind of ready for being attacked. You, on the other hand, with a public IP address, well, probably no one's trying to attack you. You're probably not being DOSed or DDoSed. It's very unlikely. So generally, you're not concerned with people knowing your IP address. especially since it has to be known in order for you to actually browse the internet. Because otherwise, well, how would the packets ever be able to reach you? Now, something you might be more afraid of would be these cookies. A cookie looks at you and sees who you are as an internet user. It can do things like look through your browsing history and decide what advertisements might be particularly interesting to you. These here are probably due to the fact that I'm on a public Wi-Fi, the school, well, kind of a public one that's used by a lot of people. So if just enough people, it's just too confused to really give me anything other than this. I probably wouldn't get this at home, or I might. I don't know. It could do other things like tell the website what language to display the website in, because if it knows that you're from America, it's going to be like, okay, most people here are speaking English, so, go ahead and show them an English page. As opposed to if I were in, a foreign country, it might give me a different language. So cookies can help personalize your experience. But you might be uncomfortable with the fact that the cookie is looking at your browsing history. It is looking at your location. So it really is just what is your level of comfort with how much is known about you as you browse the web. It might also be used by certain Flash games in order to keep your progress or keep your scores. It's just, again, it's all based on how comfortable you are with your information being out there. Moving on, licenses and copyrights. So a license or copyright dictates how something is allowed to be used. There are many things which are in what's called the public domain, meaning it is freely available to everyone at any time. If you were to go to Wikimedia, the comments on Wikimedia, and search for this box and whisker plot, you might actually find the one that I made and published there on public domain. Now what that means is, since I made this public domain, I have waived all rights concerning this image. That means this image right here, you can use in any way. And you don't have to pay me, you don't have to ask me first, you don't even have to cite me. You can claim it's yours. You can, that might be kind of silly, but you can make changes to it, you can leave it the same, you can do anything with this image. I have made it completely available to you. Now, I did say quite a few things are in here, but most things are not in the public domain. Most things might have a single user license, meaning that it's only meant to be used, installed, meaning like a software, for instance, is only allowed to be installed on a single computer. Or you're only supposed to download one copy of an album. Or maybe you're only allowed to have one copy of this picture here. This is a lovely picture you can print out and put on your wall or something. But yeah, then you have multi-user licenses that are obviously made for several people to use. Now, most licenses are going to be kind of like that. They determine how many times you have to buy it in order to put it on different computers. If you're allowed to buy it once and have it for several, or if you have to buy it every time you want to put it on a different computer. Generally, copyrights and licenses are going to be some amount of citation, some amount of actually paying, or, in the case of most books, you have to request for a written approval of the original author. That's generally how these things are. And it is considered unethical if you break that license. Moving on. Phishing. Now, phishing attacks I've kind of focused on because they're kind of funny. So most cybercrime attacks, excuse me one moment. Okay, there we go. So most kinds of cybercrime involve some kind of major technical expertise. They involve some kind of technical exploit, hacking, DNS spoofing, DNS cache poisoning, all these things. Phishing could involve that. Phishing is whatever you want to do to try and trick your victim into giving you information. So it could be I do some DNS spoofing and I make it so that way when you try to access your bank, maybe you go to Wells Fargo Bank, so maybe I go in there and I redirect anytime people try to access Wells Fargo, so that redirects to a site that I built, and so that way when you put your information in, I get it instead. That would take some know-how of how to hack into that DNS server, DN server, domain name server, and then redirect it to me, and then how to build a website that looks like the Wells Fargo website. There's a lot of technical know-how involved in there. It's also just simply emailing someone and pretending that you're the president and you need information, or just calling them on the phone and saying, hey, this is the U.S. government, give me your social security number and your birth date. It's things like that. It could be any range of things that are just about tricking someone. You could write an email that looks really convincing. Maybe it even uses official images and all that. It's just anything that's going to convince your victim into giving you information. So it's kind of funny, because phishing could be a very technical exploit, or it could be something that purely is, it's pretty simple. It's writing an email. That's it. All of it has to do with exploiting the human component of cybersecurity. The fact that humans tend to be easier to trick. Most of you are probably pretty used to giving out your information. And there was this funny story I heard once, and I'll share it. You can go and look it up later. The story goes that a certain company realized that one of its employees fell victim to a phishing scam. That they got an email that looked official, and so they sent it their username and password. So the business took a proactive approach and said, okay, we're going to email all of our employees with a picture of what that email looks like and saying, hey, don't respond to that email. It's not real. Do you know what happened? A whole bunch of people barely read that email, saw the image of the fake email that was asking for information, and responded with their personal information. Sometimes people can be very easy to trick, and that's what phishing takes advantage of. So anything you can think of that takes advantage of a person's, gullibility is phishing. Okay, moving on. High-level and low-level languages. How are we doing on time? About 12 minutes. Okay, cool. High-level and low-level languages. This here is a high-level language. This here is a low-level language. They both might do the same thing. They probably don't, because I just wrote a bunch of ones and zeros. But they both look very different, don't they? High-level languages are things like Python and Java and Scratch, C++. Low-level languages are just ones and zeros. It's the stuff that the computer can actually read. Now, when you write a program in a high-level language, the computer has to translate it into these ones and zeros so that it can actually, understand your instructions. But nonetheless, typically you will write in a high-level language and then let the computer translate it later. So that's the difference between those two. Internet packets and fault tolerance. So we're coming back to the packets again in your IP addresses. Now, when you send a message, when you send a request to a website to get that website's info so you can actually view it, you send your request packets along this long pathway of a bunch of different routing devices to go to that website, and then that website sends a bunch of packets back so that so that your browser is able to reorganize them into what that page should look like. Now, it's very important that more than one pathway exists, because if one of those pathways were to break, if one of those routing devices were to break, then we don't want the internet to come crashing down. So the website is actually the internet is very durable. And it's very durable because it allows for this thing called redundant routing, meaning that there are a bunch of pathways for any given connection. Now, the other thing that it did to be very, usable and durable is the fact that every internet packet you have not only has the data that the website was trying to give you, but it also has an address to where it's supposed to go, so that way each routing device along the way is able to pass it on to the correct routing device to make the proper pathway. But it also has a part of it that's labeled for the order of the packets. So if you were to, receive 4 packets from Google and they came in the wrong order, that's fine, because your browser is able to look at what the order is supposed to be and reorganize them so the web page looks right. Those are the 2 things that really help what's called fault tolerance, which is, can something actually, can the internet handle a fault in its system? Can it handle if something were to break? Can it handle if something were to go slower? If the packets were to take different pathways and, therefore one of them just took longer, could it figure it out? Moving on, databases. So big data can tell you a lot of things about it, and it's often used for something called targeted advertising, where based on your demographics, a website might sell different things to you. So for instance, I'm going to go to Amazon real quick, Amazon.com, and we're going to look at my recommendations. My recommendations, apparently, are based on a complex algorithm involving different things I've looked up. Now, I do have to make some criticisms here, because if I go down here, it says, something to consider for me is a police scanner. I'm not exactly sure why. Other things that it's recommended for me include things like Jesus the Christ, or the Book of Mormon Study Guide, or, oddly enough, as you saw in 4th period, where is it? A bunch of books about the demoness Lilith and Satan. I'm not sure exactly what I looked up to get all these things, but apparently, I don't know. I'm not sure exactly what's happening here. What searches gave me things like the Powers of Heaven, the Book of Mormon Study Guide, and the Bible of the Adversary. I don't know. But apparently these are all based on my search history. And that's not to say that big data is ever perfect. But, for instance, it's pointing out like, hey, Kevin, you like the Gorillaz, don't you? Well, here's a new album from them. Oh, okay. Or, oh gosh, I didn't realize the Judas Contract came out. Yeah, so it saw that I bought things like Justice League Doom, or the Justice League Apocalypse, or Justice League Under the Red Hood. And so it's like, you'd probably like some of these movies. Or you might like the new Teen Titans film. And yes, in both cases, it's very correct. So, yeah. So you see, we end up with, based on my information, it's gone through my information to figure out what it should sell to me. And that helps because now these guys probably make more money, which means that Amazon probably makes more money too. Now, data aggregation is collecting that information, is figuring out my browsing history, my gender, my age, to figure out what might be best for, just to get all those things. Now, aggregation itself is not what a data scientist does. A data scientist then does what's called data mining, where he or she goes through that database, big thing of all this information, and figures out the best way to use it. That's data science. Check out week 5 notes for a bit more about that, and maybe also check out the Simulations and Database assignment on Albert, because again, there are certain things that you're able to use the databases for, but then sometimes there are limits to it. Remember, big data is not perfect on its own. Moving on. Let's describe web servers in the cloud. How much time do I have? Holy cow. Okay, let's go on. Web server. A web server is some kind of computing device that hosts a website. The end. Cloud computing. Cloud computing is where where you save files online. So it might be using Google's OneDrive or the Office 365 OneDrive. You know, it's using these online storage spaces. You know, that's generally what we mean when we talk about cloud computing. So it's useful because you can go from one computer to another and access the same files so long as you can access the internet. It means that, let's say I don't have a computer for a little while, which happened to me in college, and so I have to go from library to library using different public computers. I can't save anything on those computers, but if I can save them on the cloud, then as long as those computers can access the internet, I can go to each of those computers and still get my schoolwork done, which is what I did for like a certain semester in college. Now, one thing that's kind of a tricky issue with cloud computing, just a little drawback, is the fact that it's technically less secure. Because if I had a computer that was never connected to the internet, it's far less likely to get hacked than, you know, Google's OneDrive or Microsoft 365's OneDrive. Generally, any big name cloud service like Google, Microsoft, you know, things like that, they tend to be pretty good about their security and preventing hacks. But that doesn't mean it hasn't happened before. Yahoo's, for instance, Yahoo has been subject to quite a few hacks recently, at least 2. A lot of user information has been stolen. Yeah. Moving on. Heuristics. A heuristic algorithm is an algorithm that gets an approximate answer for an extraordinarily difficult problem. It's used a lot in encryption algorithms because when you encrypt something, generally, when you're doing like a really good thing, not just, you know, a Caesar cipher or a Vigenère cipher, but doing like a really tough, you know, encryption, then you might use what's called an intractable problem, which is a math problem which takes, even with a computer, maybe a few hundred years to solve. So your heuristic algorithm is going to solve most of it. For instance, let's say it had to get it to a certain decimal place, so it got like 10 decimal places in, but there's 10 more to go to get the actual correct answer. It might go ahead and stop right there, because maybe the first 10 decimal places take like 10 seconds to get, but the next 10 decimal places take 247 years. So it might just stop right there and return that approximate answer rather than get the exact answer. In any case where you have a problem that it takes too long to do, or is just plain impossible, then you would probably use a heuristic algorithm. Moving on, digital divide. We're almost at the end. Not really. Anyways, digital divide is the abstract concept of the division between those who have access to computers and the internet and those who don't. This is generally based on age and class. However, if you notice a Pew Research study from 2012, according to half of the non-internet users in America, the main reason why they did not access the internet was because they just didn't feel that it was relevant to their lives. Now that's kind of an interesting case, and I'm betting that as we go on further, more people are going to be accessing the internet because they do feel it's very relevant. You know, you and I are probably in that category of finding the internet relevant to our lives, being as how I run a YouTube channel, you know, a moderately successful YouTube channel, and you're watching one. But yeah, there are a lot of reasons why someone might not be able to connect to the internet. It could be education, like they don't really know how to get there, or education because they had a lower level of education, they have a lower paying job, and are not able to afford a computer. You know, all these are options. Check out a bunch of reasons for why the digital divide exists in different places in America and elsewhere, and you're going to see a lot of different reasons for why. All right, Overflow. Let's talk about that. This big amount of paragraphs here describe what Overflow is. I'm going to try and give you a short description. If you don't get it, check it out. Okay? Now, Overflow. Now, let's say I had 3 bits. Okay? That means 3 binary digits where I can represent with either 0 or 1. Now, if I wanted to represent the number 5, I could, because that's just 1, 0, 1, right? If I wanted to represent the number 6, I could, because that's just 1, 1, 0. If I want to do 7, I can do 1, 1, 1. But if I want to do 8, I don't have enough space for a 4th bit. So instead of having these 4 bits, I can only have 3. So I do what's called overflow. Because I ran out of bits to fill it in, I actually overflow from the topmost number I can represent with those few bits, and to the bottommost number I can represent with them. In this case, it's not 8, instead it's 0. Because I only have 3 bits to represent my information with, so the largest I can do is 7. If I try to add 1 more onto it, it's going to overflow back to 0. Now each of these bits are called registers. So whenever you see things like 32-bit architecture, like a computer that's 32-bit versus a computer that's 64-bit, and then you look it up online to figure out what that means, and they say, oh, it means it has 64 registers. All that means is that there are 32 or 64 bits to hold programming instructions. You know, the low-level programming instructions from right here. So for instance, this one has 32 bits, meaning this is a 32-bit architecture, because each programming command has only 32 bits in it. If I were to have an architecture like this one, that's 64-bit architecture. This is what most computers today will have, but there are some that still have 32-bit. Moving on. Searches, sequential and binary. Sequential search is where you search through an array or a list and you look for some query. If you find that query, you say, yay, I did it. If you didn't find that query, then you didn't find it. Now, a linear search just goes step by step, checking every single element until it finds it. Now, more complex than that is a binary search. And, oh crap. If I assign this section to you, please read this section, okay? If I assigned you section L for study, read this section. Same goes for section K. Sections K and L, I want you to read if I assign them. Absolutely. Now, going on. Another kind of search exists called binary search, where it splits the list into 2 and goes like that. Now, this list has to be sorted. So take, for instance, if I were to search for the number 7 in this list here. Now, it's going to first look at the middle element. And if that middle element is bigger than the number we're looking for, like in this case where 20 is bigger than 7, it's going to ignore all the values to the right of 20 and instead look at this half of the list. I think I have a mouse here. Let me use that. This half of the list and find the middle element of that part. Then, if that wasn't it, it'll go ahead and look at that half of the list and figure out that half of the list and see what the middle part of that one is. In this case, it was 7. Now, I can also go ahead and color those sections green, which it's now going to ignore. So that's what I did right here. And you'll see that whereas this one, a linear search, would have had to go step by step going 1, 2, 3, 4, 5 times before it actually found it, the binary search does 1, 2, 3 searches on this. Now, if 7 was not in the list, then obviously it would have to have checked that one and then checked that one, meaning that the most it would have to have checked is about, it would technically be 5, right? This is basically log base 2 of however many elements we have. For my computer science A kids, that's the hint for you for how long binary search takes to go. It's log base 2 of it. Just telling you. Next up, metadata and data. Oh, I didn't talk about that. Okay, go ahead and search that for yourself. Nah, I'm kidding. Okay, metadata, let's write this. Metadata is any data that describes data. Now, the example I wanted to use was a phone call. So, for instance, a phone call has the actual data of the two people's voices, right? You know, the actual things you say. But the metadata would be the phone numbers, the duration of the call, when the call was made, things like that. Now, metadata became very popular of a search term recently because the NSA was found to be looking at metadata for a bunch of phone records. And there was a question of, what does that actually mean? Well, it means they would know who you called, and for how long you talked, and when you called. It's debatable as to how much they would actually know about you, so, maybe you check into a little more to decide how comfortable you are with that kind of thing. That would determine what side of the surveillance debate that's currently raging on you would fall. That you would be on, upon which side you would fall, on which side you would argue for. There are arguments for, both whether or not this is actually all that serious, or if, it could be used to find terrorists, or, so on and so forth. But that's what metadata is. Metadata describes your data, how long that call lasted, who was involved in the call, when the call was made. And all these things could actually tell you quite a bit about yourself. This can also be used by certain police forces if they wanted to find out, this might be used by a police force if they had a known criminal. So let's say this. If a police force had the metadata for a known criminal's phone, then what could they do? Think about it. Well, they could then look at all the other numbers this person called and investigate them, especially if those people talked for a long time. Certain things can look a little more guilty in that case. It helps police figure out webs of criminal activity at once. That's how metadata can be used by a police force. Metadata has also had some other interesting experiments. I believe NPR had a report that was really cool about it. Go check it out online. Anyways, moving on because we're about 33 minutes in. Let's move on. How to read pseudocode. Honestly, I need you to just read this section. You gotta go and trace it. Look at my other tracing videos because I have a whole bunch of them on my YouTube page. If you go to my YouTube page and then you go to let's see, Video Manager, and I went to my playlist for AP CSP tracing, you'd see some tracing things here that would help you out. So go ahead and check out those out. Alright, moving on. Lastly, two things. SMS, short media service, or something like that. Short message service. That's basically text messaging. They are handy for communicating short blasts of information. And sometimes other organizations use them. I know the Humane Society of the United States uses it to blast out to a massive mailing list to go ahead and tell everyone updates on, their funding, what they're currently doing to help animals, all that. There's a similar kind of thing happening with Amber Alerts. It's not exactly a text message, but you noticed that you began receiving an Amber Alert on your phone just automatically, like it began ringing and saying, "Hey, Amber Alert." I remember this happened to me for the first time in a Taco Bell. I was there with a friend, and suddenly everyone's phones just began like buzzing, and we were all like, "Whoa, this is really trippy." And then that just became a regular thing in our lives. Became a part of what our lives are now, is the fact that we get these Amber Alerts just on our phones. So things like that are used, like short messaging service or other kinds of ways, might be used by various entities because they're really good for communicating short bits of information really quickly. Lastly, the opposite of greater than or equal to is less than. I want you to just process that. Think about that. The opposite of greater than or equal to is less than. The opposite of less than or equal to is greater than. The opposite of greater than is less than or equal to. The opposite of less than is greater than or equal to. And that's that. Thanks for watching, my faithful subscribers. Bye. Have a good one.